Thank you very much. It's a great pleasure to be here and to give this talk. Stephen apologizes that he could not be here to give it in person. He and his wife are expecting to grow the Chi community by one very soon, and so he felt like he needed to stay in Ann Arbor. So everybody here has used multi-touch applications on tablets and smartphones and even on your watch. They're usually very easy to use and pretty natural, but the problem is that they're very hard to implement. And one of the reasons this is because of all of the different pieces of information that you have to control. So most multi-touch frameworks that you might program with have some fairly straightforward event types: touch start, touch move, and touch end. So these are pretty straightforward. They seem pretty simple to use. Each of these has a variety of properties that you can use in your programs, such as the position, the ID, the timestamp, and for many devices, the force. The problem is that when you try to use these in a gesture that fires, when you have two fingers or multiple fingers and you want to have movements, then it gets to be a lot more complicated. So let's see what the requirements are for the different events. So rather than writing code, I'm just going to list the specific requirements. So first, for the touch start listener, in order to know whether the user should start the gesture, first we're going to have to count the number of fingers. And that count has to be a global variable, so I'll put it in this gray box to show that it has to be outside of the gesture handlers. And of course, this global variable is going to have to be incremented and then read from the start handler. You'd also want to, of course, clear it from the end handler. And you probably are going to want to have a timeout to make sure that the two fingers touch the screen at about the same time. And that also has to be read in multiple places. Also, we might want to know that the two fingers go down close to each other, and then you have to measure the location. And that, of course, would have to be updated based on if the first finger moves before the second finger goes down. And also, that also has to be dealt with on release. So we have all of this code already just to make sure that you have two fingers down. But now we have to deal with moving them, which has a bunch of other requirements in code and callbacks that you'd have to do. So all of these also can happen in almost any order, and we're dealing with event handlers and global variables, so all sorts of multiprocessing kind of coordination has to come in as well. So what could we do to try and simplify this level of complication and to try to have more understandable primitives that you could program out of? And so what we are doing is to try and understand how we can make this better for programmers. And the first thing we did is a pilot study using this technique we call natural program elicitation, which is where we try to understand how programmers would naturally want to express these ideas. And typically they write them down on paper with a pencil, not necessarily even using a computer. And we ask them to invent any primitives they want. And they can either use these in code and text, or they could even draw pictures. So when we asked them to write code for the press, you remember we had a lot of requirements that they would have needed otherwise, but what people tend to write is just a fairly simple press, and they would have an event that said two fingers down, and that would be the event they have. And then when we asked them about how they would naturally express movement, instead of writing a bunch of code, they would typically draw a picture like this vertical line to show what they had in mind in terms of the reference for the event. So we were inspired by these natural ways of expressing things to provide a toolkit with two different fundamental operations in it. One is touch groups that you can use to express a group of fingers doing an operation. and then it can fire a single event for your application, for example, when 2 fingers go down. And then we added cross events, which is a set of events that you can use to describe the movement of the touch groups, and they provide an easy way to identify when the touch event goes past a particular position. In order to support the kinds of behaviors that people want to express, we arranged for the crossing events to be an arbitrary path, so you can define any path at all with SVG, but most of the time people just use lines and circles because those are the most common and simplest thing to do. Another important aspect is that the cross-event parameters, like where they are physically on the screen, can be computed with constraints. So a constraint is an equation that the system maintains for you, and this allows the paths to be dynamic. They can depend on where the event starts and so forth. So here's a simple example. We can say that the X position of the crossing event would be based on wherever the touch goes down. That one's not particularly useful. Much more common would be to say the X position depends on where the gesture starts, right? And so then you can tell whenever the fingers move more than 10 pixels away from where they started. And these paths can be any shape. For example, if you wanted to make sure somebody presses down and does not move, then you could draw a small circle around the original location and say, cancel the event if it ever moves out of this little circle. So how would you use those events and crossing paths in order to program our little example? So first we create a touch group, and we'll call it T, and we can specify that it has to be 2 fingers down at the same time. Everything else we leave as the default values. And then we define a path P that's, again, to the right of where the gesture starts, and let's call it 20 pixels away. And in terms of the vertical distance, it would have to be, say, again, 30 pixels above and below where I started pressing. And that's all you have to do, really. So now you can say when this particular thing happens, when the touch group crosses this line, then whatever code we wanted to have happen in that particular situation would then occur. So that's kind of very simple. That's a lot of what you need, but as soon as you have things like crossing and multiple presses, you immediately have the issue of conflicts that multiple groups might fire at the same time. And so we have a whole system of priorities and different flags that you can use in order to fairly straightforwardly prioritize between the different kinds of events. In order to understand to what extent this system was usable by programmers, which I'm sure many of you know is a really hard thing to identify, we ran several different evaluations. The first one we did was a readability study where we wanted to make sure that people could understand our crossing event kind of code. So what we did to do that test is we showed people the 2 different kinds of code, in this case the touch event code on the right and conventional JavaScript on the left. And then we asked them to evaluate them. This study lasted about an hour for each of 18 participants. They all had prior programming experience and user interface experience. And they had basically 20 questions, 10 with crossing events and 10 with conventional JavaScript, I mean. And at the bottom is basically the test. They're supposed to look at the code and pick which of the gestures at the bottom this code implements. Naturally, we controlled for order so that half of the group got the touch events first and half of the group got the JavaScript first. And the kinds of gestures that we tested were standard gestures that you would imagine from any of your common apps, as well as some custom gestures, discrete and continuous gestures, Also static and dynamic gestures where the value moves, like like scrolling or zooming, where you end up wanting to know the time basis of the gestures. And then, of course, one finger and multi-finger gestures as well. We didn't see any difference in the different kinds of gestures across the performance, but we did see a statistically significant difference in both the accuracy and the time for reading the code, and luckily for us, the control group was worse. Our experimental group did in fact do better. And we interviewed the participants after the study, and they said nice things. The standard touch events were easier to understand on paper, so just conventional down, up, move sounds easy, but it turns out to be pretty difficult when you actually see it in the code. Another participant said the standard touch events load a lot of information into those three functions, so it can often be difficult to read and understand quickly. Event handlers like that are just generally kind of a mess to read. So it's also important that this code can be written, and so we did another user study where we asked people to write some code. We had 10 different participants do this study. Again, it lasted about an hour, and we had 3 different conditions that we asked everybody to write their code in. Obviously, we trained them on all these 3 and controlled the order. In the control condition, they just wrote code using conventional touch events in JavaScript. In the first experimental condition, we used the touch events embedded in JavaScript, the touch groups embedded in JavaScript, as I was showing before. And this time we added a third experimental condition, which was having a graphical user interface to represent these gestures in kind of a declarative style. And this integrated with Stephen Oney's thesis system, which was called Interstate, which was a graphical way of doing transition diagrams. So in this case, they could define the same events as they did before, but this time there was menus that would pop up the different options and so forth. So again, we asked this participants to implement 3 different gestures taken out of a large set of gestures that were standard and more custom kinds of gestures. We randomized the assignment of gestures to conditions and the order in which they were done. I should have mentioned before, by the way, that in the reading experiment, we had an external person write the code. So it wasn't any of the experimenters who wrote the original code. And similarly here, we had an external person grade the implementations to try and avoid bias. And we tested their code in a variety of pre-scripted situations. So unfortunately, we didn't find any statistical significant difference, either in time or in accuracy for the Readability study, although the trend is in the right direction. And we can say it certainly wasn't any worse, even though these people were highly experienced in writing conventional touch code in JavaScript. In the interview, the participants were very positive. The ability to specify the path to say exactly where you want the event to actually cross was helpful. Instead of trying to calculate it yourself, just be able to make a circle, to make an event handler for crossing that line. Instead of trying to calculate where those points were and where they are now, it's nice that the circle can update its position based on the object. So beyond readability and writability, we'd also like for this mechanism to be general purpose. It can be used in lots of different situations. So we went to the prior HCI literature, collected a whole bunch of different gestures that people had reported in previous papers at Chi and WIST and so forth, and we implemented those in touch groups, and the details are in the paper. So in conclusion, we introduced 2 new primitives for multi-touch programming, touch groups, which describe multiple touches that happen in synchrony, and touch and crossing events, which summarize the movements of those touches. We conducted a readability evaluation where we found that participants, in fact, were able to better understand than imperative code written with touch groups and cross events. And then we conducted a writability evaluation where we found promising results, but because of improvements with time and correctness were not statistically significant, we can only really say that participants' performance was on par with standard touch events. Thank you.
If you have any questions for the speaker, we've got 4 microphones in this room, 1 here, 1 over there, and 2 at the bottom of the tiered seating. So,
and I have to say that I'll try to answer any easy questions, but if you have hard questions, Stephen did an awful lot of work on this on his own after he graduated, so we'll have to send him an email.
Well, hopefully an easy question, Brad. Jeremy Cooperstock from McGill University. You're the tools man. You've been at this for so many years, and I'm fairly new to this space, but I just can't imagine that multi-touch primitives are not already a staple built into OSs of all of these underlying systems. Why is it that such a study is still relevant in today's age?
Yeah, so if you look at Android or iOS, they basically have touch start, touch end, touch move, which is fine for single finger programming, but really doesn't help very much with multi-finger programming. And they have a lot of the standard operations built in. So, 2-finger zoom or 2-finger scroll. You just get a scroll event. You don't actually have to handle that yourself. But, a lot of standard apps that we use all the time, including, say, Google Maps, have custom multi-finger behaviors. And it's still the case that you have to program those by hand from low-level touch events.
Shouldn't this reflect poorly on our community?
I certainly agree with you on that.
Do we have any other questions? Don't be shy. Okay, so I have one. Could the cross events framework be used to capture more complex trajectories? So stroke gestures, for example.
Yeah, so obviously it's not appropriate to use this for things like character recognition. You could do some simple crossing, like if you wanted a C gesture or a circle gesture, that could be done. But we certainly didn't intend for this to be like a recognizer for handwriting or, some really complex gestures. But through the survey of almost all apps on phones and tablets and almost all of the research papers, we can really cover a substantial number of the gestures that people really use.
Any more? One last one then. Do yourself or Steve have plans to release any of these tools so that others can use this themselves?
So this particular implementation is built into Stephen's Interstate system, which is available for downloading. But I don't think he has any particular plans to release it separately.
Sure.
But there are enough details in the paper that you could reproduce it fairly straightforwardly.
Okay. Let's thank our speaker again.